My team are supplying the actual nanomaterials that are being used in studies and experiments throughout the NanoFASE project. NanoFASE is trying to understand how the nanomaterials in everyday products get into the environment and where they go once they're in the environment. So for example, particles in sunscreen can wash off into the sea when you're swimming, or they can get washed down the drain, for example, when you have a shower at the end of the day. One of the big challenges we're addressing in NanoFASE is that any particles that reach the environment are very hard to track once they get there, because there are many other particles that have similar sizes and similar elemental composition. So we're developing in NanoFASE solutions whereby we're adding a second element, a second component into the nanoparticles that we study. And then if we identify both of these components together, that tells us that it's our nanoparticle. Visitors will find information about the types of nanomaterials that we're studying and the methods that we're using to study them. As an example, a material that's released into the air, so if it's abrased off a surface, for example, or the road, into the air, it might then deposit on soil and move through the soil column into the groundwater, or from the soil could get taken off by an organism such as earthworm that lives in the soil. We're specifically interested in understanding how the surface of the nanomaterial is transformed in the environment and the processes driving this. So these can be physical, such as abrasion or shearing, or they can be chemical reactions at the surface, such as sulfidation or oxidative dissolution. Another type of transformation is where things that are present in the surroundings, so in the soil or the water, absorb onto the particle surface. A final type of transformation that can occur is biological transformation. This is, for example, where the bacteria or other organisms present might take up the particle and then degrade it biologically using enzymes, for example. From industry will find the very latest information on the fate of nanomaterials in the environment, where in the product life cycle the nanomaterials are likely to be released, and the consequences of the release in terms of these surface transformation reactions that will occur. This information can be utilised by industry to design nanomaterial properties that facilitate these transformations in order to lead to final functional fate groups with lower toxicity or lower exposure. So for academic visitors, one of the most important outcomes from NanoFASE is our dedication to fair data. So that's making the data we generate in the project findable, accessible, interoperable and reusable. And through our collaboration with the research infrastructure project NanoCommons, researchers will be able to access all of the data sets generated for each of the nanomaterials in each of the environmental compartments. Visitors to the applicable framework with a regulatory background will find the environmental reactors and the functional fate group concepts particularly relevant. There are already calls from regulators for testing of the environmentally aged variants of nanomaterials, in addition to testing the pristine as produced nanomaterials.